Hey everybody, welcome to the second edition of the Flipped Classroom at Anson Jones Middle School, 8th grade science. This is Mr. Borrego for Mr. Masters and Mrs. Martinez. Today we're going to look at the Bohr model. Last time we talked about the atom. Before we do that, we're going to talk about the Cornell style notes. Remember, you need to set up your paper like this before starting your notes. The atom notes and these notes are due on Monday. So you have the weekend to do this. Don't forget topic, your questions go on the left hand side, the notes or the answers go on the right hand side. And don't forget your 2 to 3 complete sentence summary. Okay, let's go ahead and take a look at the questions. Go ahead and pause the video now and write down the questions. Alright, a lot of you were asking, well, what's a Bohr model? Well, a Bohr model is a two-dimensional representation of atoms. They help us locate the subatomic particles of each atom. Subatomic particles, that sounds familiar. We learned that in the atom notes. Can you think of them? There are 3. Let's take a look at the next slide to see if you're correct. Protons, neutrons, and electrons. The Bohr model is to show the locations. So, protons and neutrons in the nucleus. Positive proton, neutral neutron. And the electrons outside the nucleus here. And they are negative. So the purpose of the Bohr model is to show the locations. Now, if you can't remember subatomic particles, what they are, here's a little something for you to remember by. Pin. Don't forget your pin. Protons, electrons, neutrons. So this is another way for you to remember it. Bohr models. So the identity of the element is represented by the number of protons found inside the nucleus once again. So here carbon has 6 protons. Alright, it determines the identity of that element. So if we change this to a 7, it becomes somebody different. It's a new element. If we add another one, it becomes 8. It's a new element. So for carbon, there are 6 protons. Neutrons and protons make up the atomic mass. So here the decimal number 12.011. This is the mass. The neutrons and protons make up that mass. Again, here is the number 6, the atomic number, the number of protons, the mass. We have the protons and the neutrons together. Introduction to valence electrons. Remember little electro? Let's talk about the electrons. Once again, the valence electrons are the electrons on the outermost energy level. They are the furthest away from the nucleus. So here are all the electrons, but the valence electrons are the ones furthest away. So 1, 2, 3, 4 from the nucleus right here in the center. And again, the protons and the neutrons inside. The number of valence electrons can be found by looking at the group number. So if I said, how many valence electrons does helium have? We'll just look at the group number, 18. But when it's double digits, you only use the second digit. So helium will have only 8. Only 8. So how many valence electrons does chlorine have? Where's chlorine? There it is. Right here. How many valence electrons? Can you guess? If you guessed 7, you were right. 7. What about oxygen? How many valence electrons does oxygen have? 6. Okay? And the groups, again, are vertical, up and down. Up and down. Valence electrons determine an atom's reactivity. Valence electrons determine the chemical properties of an element. The fewer number of valence electrons an atom has, the more reactive it is. What is the reason for this? Well, if you remember from today's activity, the Where's Al activity, remember all those cousins that you had to cut out? Some of them were happy, some of them were sad. Well, why? Okay? Well, think about it like this. If you have a little baby, okay, and you take away all the baby's toys, it's probably going to cry, right? It's probably going to move, and it's not going to be happy. It's going to be very sad. But what if you give them a lot of toys? Let's say you give them 1 toy, 2, 3, 4, 5, 6, 7, 8 toys. That baby's going to be very, very happy. Okay? It's not going to go anywhere. It's not going to be sad. It's going to be very happy. So you can think about the elements this way. Okay? The fewer number of valence electrons an atom has, the more reactive it is. Okay? So that's why some of those cousins in today's activity were sad, because they had less valence electrons. And the ones that were very happy had more valence electrons. So if they have fewer number, that means they're going to be more reactive. Okay? So that wraps up this session of the Flipped Classroom. Remember, the notes, the atom notes, and the Bohr model notes are due on Monday. No excuses. Okay? Make sure you have the questions and the answers. We're going to go over it and check your notes. So if you have any questions, please come with them to class. We can clarify, we can work them out, and talk about them again. All right? Thank you. We'll see you on Monday.